topic of today is that is the salt affected soils. First one is saline soil. By the name itself, saline soil having excess soluble salts. What are the salts? Which salts? The salts can be sulfates or chloride. Sulfates and the chloride salts of calcium, magnesium, sodium or potassium. This soil contains the excess salts of sodium or chloride salts of calcium, magnesium, sodium or potassium. Let me erase this. You remember this definition. You better make a note of this topic. And we can we mainly see these kinds of soil in arid and semi-arid region because here the evaporation is more than the precipitation, as we have already discussed. See, for example, this is a soil containing some water, right? Water contains salts. When there is a, for example, this is the sun. When there is a high temperature, water gets evaporates. Water get evaporates, but whatever the salt present in the water, it accumulates here on the surface. It accumulates on the surface. This is all the salt. So we know the salt is in white color. You can see here. That's why the saline soils are called as white alkali. That's why the saline soils are called white alkali, and they are also called as solancha. Solancha. These are the other names of saline soil. You please remember this. We usually see them in a arid and semi-arid region because we can see the deposition of salt on the surface, and these are formally called as white alkali. And in India, these soils are also known as Ray and Thur. These are the local names. You remember this. And the characteristics, some of the features, because there is a excess concentration of soluble salts. Soluble salt means this is the chloride and the sulfates of sodium, calcium, magnesium, potassium. These are the excess amount of soluble salt. Because of the excess salt, it becomes toxic, and these hinders the absorption of other nutrients as well. We have already discussed some of the feature. In saline soil, the electrical conductivity is more than 4 decisiemens per meter, and the exchangeable sodium percentage is it is less than 15%. And the pH we already know, it is less than 8.5. You remember these three characters. These are the important characters. And the soluble salt concentration is more than 0.1%. How we can reclaim these soils? How we can reclaim in the sense how we can get back this how we can make these saline soils into a normal soils which is conducive for the plant growth. How we can reclaim? See here, one of the best way to reclaim the saline soil is leaching. See, this is the soil containing some of the soluble salts. The thing is, we have to remove these soluble salts. So that's why we have to irrigate the field to leach all the soluble salts. And we have to consider here is we have to follow the controlled leaching, because there are some salt which are beneficial for the plant growth. We have to maintain some salt concentration in the soil. We should not remove all the soil, all the salts present in the soil. So we have to remove only excess salts. So that's why we have to follow controlled leaching process. The things to consider while for the control leaching is which quality of water we are using. The quality of water matters here, the quantity of water matters here, and the drainage facility also we have to consider these things while leaching. Quality means the whatever the water we irrigate to the field, that should not contain salts, that should be low salt, low in salt. We have to consider this. And in terms of quantity, this quantity depends on the root zone. For example, if the root zone is 25 to 30 centimeter, then we have to supply enough irrigation water to remove the excess salts. Based on the root zone, we have to supply the adequate amount of water. In case of drainage, if you are supplying the adequate amount of water, there should be a proper drainage so that whatever the salt present in the soil, it get leached. One of the easiest way is to the leaching is one of the easiest way to reclaim the saline soil. So the flooding and the leaching of soluble salts, the only primary objective of flooding is to remove the excess salts. We can use a farmyard manure, and based on the salinity we can choose the crops. We can grow some of the salt tolerant crops. The next one is alkali or sodic soils. Here, this is also salt affected soil. Here we can see the excess amount of sodium salts. Excess amount of sodium salt. For example, Na2CO3, sodium carbonate. This increases the pH of soil. We already know that alkali or the sodic soil, this is another name of sodic soil, having more than 8.5 pH. Why? Means this sodium carbonate increases the pH of soil, and this soil is also known as solanates. You remember this word, this is important. Here the soluble salt concentration is less than 0.1%, whereas in saline soil it was more than 1%, more than 0.1%. It is usually occur in rainfall area having rainfall more than 55 to 90 centimeter. The pH is usually between 8.5 to 10. We have already know some of the feature like electrical conductivity is less than 4 decisiemens per meter, whereas the exchangeable sodium percent is more than 15%, and the pH is more than 8.5%. These are the primary character you have to know. Because of due to the high ESP exchangeable sodium percent, soils are dispersed and deflocculated. Because of this condition, the soils are not good for cultivation. Means soils are having a bad physical properties. Bad physical properties in the sense there are some aggregates, low percolation. Low percolation means there is a it affects the root growth. Ultimately, the productivity of the plant, productivity of the crop. In some part of India, they are also called as usar or kallar. Remember these terms. Some of the tolerant crops for the sodic soil are rice, sugar beet, and dahincha. Medium tolerant crops are wheat, barley, oat, millets. Sensitive crops are legumes and maize. How we can reclaim the alkali soils? We already know there is a high exchangeable sodium salt. There is a high amount of sodium salt. That's why they are called alkali soil or sodic soil. We have to remove this excess amount of sodium salt. How? Means we have to replace this sodium salt with calcium or magnesium salt. For example, the sodium is present on this clay particle. We have to remove this with calcium or a magnesium salt. For example, this is a clay particle having a sodium, excess sodium. We have to apply the gypsum here. In case of alkali soil, we apply gypsum. What is the formula for gypsum? Chemical formula. It is CaSO4 2H2O. What we get is this Ca occupies the place of this sodium salt. So now after applying gypsum, what we get is the clay having the calcium salt, whereas the sodium salt it gets away. This becomes Na2SO4. This calcium replaces the sodium salt. This is how we can reclaim the alkali soil. Gypsum is used for the reclamation of sodic soil. Iron pyrite can also be used for the amendments. Green manuring or application of farmyard manure are the one of the way to reclaim the sodic soil. Cultivation of salt tolerant crops. In case of saline, the gypsum should not be recommended because sulfate also increases the salt concentration. That's why in case of saline soil, we go for leaching. And we have already discussed the third type of saline alkaline. We already know the features of saline alkaline soil. Saline alkaline soil is nothing but this having a electrical conductivity more than 4 decisimon per meter and the exchangeable sodium percentage is greater than 15%. And the pH in saline alkaline soil, the pH varies. It can be less than 8.5 or it can be more than 8.5. Depends on the salt concentration. See here, that's what it is given here. The pH is variable and usually above 8.5. Usually it is more than 8.5. But depending on the relative amount of exchangeable sodium and soluble salt, when the soil is dominated by the exchangeable sodium, the pH will be more than 8.5. When the soil is dominated by the soluble salt, the pH will be less than 8.5. You just go through once. We will see the difference between saline soil and sodic soil briefly. So we have already know the different names of saline soil and the sodic soil. The saline soil, we know there is a white crust, hence it is called as white alkali. In case of sodic soil, there is also white crust because it is also salt affected soil, and we can see the localized black color spot. That's why it is called as black alkali. Another name of sodic soil is black alkali or alkali soil. Localized black spot, we can see the localized black soil. Here the saline soil is having a good physical condition. Good physical condition means there will be a adequate pore space will be there. If there is adequate pore space, there is a good permeability will be there. There is no water logging because there will be a good drainage condition. Remember this, saline soils having a good physical characters, whereas the sodic soils are poor in physical condition. We have already discussed because of the deflocculation, there is a poor physical condition. Because of the poor physical condition, there is a water logging because of the poor drainage system. The soils are becomes hard and cloddy in case of sodic, and there is a failure of crop ultimately. In case of saline soil, they are having a good physical condition. Here the failure of the crop is due to high salt concentration. Here the failure of crop, in case of sodic soil, the failure of crop is due to the poor physical condition. You just go through once. Let us move on to the next type of soil, that is calcareous soil. So the calcareous soils are usually prevalent in arid and semi-arid regions. We can see the calcareous soils in arid or semi-arid regions. Calcareous soil, by the name itself, you can say that there is a presence of high concentration of I hope it is visible, high concentration of calcium. There is a high concentration of calcium in the soil. Calcium in the sense calcium carbonate, that is CaCO3. There is a high concentration of CaCO3 in the soil. That's why the soil is called as calcareous soil. And this CaCO3 is also in white in color because it is also a salt. So, in order to identify the soil, whether the soil is calcareous or not, we can easily identify the calcareous soil because when these soils are calcareous soils are when these soils are treated with acid, it can be H2SO4 or HCl. When these soils are treated with acid, they form froth, or there is a formation of bubble. What we say in chemistry is effervescent. There is a formation of bubbles in the soil. So that by this feature we can easily identify whether the soil is calcareous or not. See, there is a calcium carbonate in the soil. If we treat with HCl, there is a formation of carbon dioxide. By this reaction, there is a formation of carbon dioxide. This creates a bubble. Because of this, there is a bubble formation in the soil. So we can easily identify with this process. They are often fertile. And sometimes the calcareous soils are flinty, thin, and dry. There is a high concentration of CaCO3, as we have already discussed. See here, the calcareous soil contains enough free calcium carbonates. See how there is a formation of calcium, calcareous soil. What is the genesis? How they are formed? Because in order to form calcareous soils, these soils are formed from the rock containing high calcium carbonate. What are the rock containing high calcium carbonate? Can you give some example? Can you remember the rock or the material containing high calcium carbonate? For example, limestone, calcite, dolomite. These are the rock and minerals containing high amount of calcium carbonate. When these rock get weathered, there is a formation of calcareous soil. This is one of the reason how calcareous soils are formed. One more reason is we can see this calcareous soil in arid and semi-arid region. Why? Why only in this region? For example, I'll explain here. This is a soil containing calcium carbonate, excess amount of calcium carbonate. Because of the arid and the semi-arid region, there will be a low rainfall, right? There is no adequate rainfall. That's why these calcium carbonate stay in the topmost soil. If there is a high rainfall, these calcium carbonate will get leached into a down layer. Because of the low rainfall, these calcium carbonate stay in the top layer. That's why these type of soils are found in semi-arid and arid region. There is a accumulation of salt on the top layers. The next one is means what? If there is a high rainfall or a continuous rainfall, this CaCO3 leached beyond the root zone. And the next another feature of this calcareous soil are these calcareous soil having pH in the range of 7.5 to 8.5. The pH range of calcareous soil is 7.5 to 8.5. For example, if there is a CaCO3 in the soil, it combines with whatever the water present in the soil and the carbon dioxide present in the soil. It forms calcium hydrogen carbonate. Calcium hydrogen carbonate. This increases the pH. That's why these calcareous soils having the pH range of 7.5 to 8.5. This is not normal. Usually the nutrients are highly available in the range, pH range of 6.5 to 7.5. In this range, the nutrients are available. Most of the nutrients are available in this range because of this reaction, the soil becomes, the pH of the soil increases. And one more reason, the problem associated with the calcareous soil is, give me a second. There is a hard surface in case of calcareous soil. See, this is a soil surface. There is a hard, hard pan or hard subsurface developed in this region because these calcium carbonate combines with the clay material present in this region. It forms hard pan. hard subsurface. This is one of the another feature of calcareous soil. The next one is what are the problems? What are the problem associated with the calcareous soil? See, because of the high concentration of calcium, there is a toxicity. This hinders the absorption of other nutrients by the plant, and there is also a high pH, that is 7.5 to 8.5. This also reduces the absorption of other nutrients like iron, copper, etc. And these type of soils also have the less amount of organic matter, and there is also a formation of crust. As we have already discussed here, there is a formation of hard pan or the crust. These are some of the problems associated with the calcareous soil. I advise you to go through the PDF once. This is what the summary of this. How we can reclaim this calcareous soil? How we can manage? How we can amend? How we can get this soil, to the normal condition? One is leaching. One is we have to leach whatever the excess carbon, calcium carbonate. How we can remove it? With the help of acids or acid formers. Acid formers. With the help of acids like H2SO4, we can remove the CaCO3. See, acid, when we apply acid, it neutralizes the pH. So the soil becomes neutral. Soil becomes neutral. So the material or whatever the nutrients present in the soil will be available for the plant growth. So this is how when we apply the acid, it neutralizes the pH of the soil. Then it will directly help in the absorption of nutrient by the plants. This is how we can reclaim the soil. Another one is we can apply the green manures. This is a one more and one more thing is we have already know there is a formation of subsoil surface, and there is a hard pan or the crust. We can break this with the chisel flow or a subsoil flow. With the help of this, we can reclaim the calcareous soil.